Okay, 35.3 is fighting infectious diseases. So more than 200 years ago, English physician Edward Jenner noted that milkmaids who contracted a mild disease called cowpox didn't develop smallpox. So at the time, smallpox was a widespread disease that killed many people. Could people be protected from smallpox by deliberately infecting them with cowpox? So how do vaccines and externally produced antibodies fight disease? A vaccine stimulates the immune system with an antigen. The immune system produces memory B cells and memory T cells that quicken and strengthen the body's response to repeated infection. Antibodies produced against a pathogen by other individuals or animals can be used to produce temporary immunity. So, acquired immunity. Dr. Edward Jenner performed an experiment in which he put fluid from cowpox patient's sore into a small cut he made in the arm of a young boy named James Phipps. As expected, James developed mild cowpox. 2 months later, Jenner injected James with the fluid from smallpox injection. The boy didn't develop smallpox. The boy's cowpox infection had protected him from the smallpox infection. So the injection of a weakened form of a pathogen or of a similar but less dangerous pathogen produced immunity is called a vaccination. The term comes from the Latin word vacca, meaning cow, as a reminder of Jenner's work. Active immunity may develop as a result of a natural exposure to an antigen, fighting an infection, or from deliberate exposure to an antigen through a vaccine. Vaccination stimulates the immune system with an antigen. The immune system produces memory B cells and memory T cells that quicken and strengthen the body's response to repeated infection. Antibodies produced against a pathogen by other individuals or animals can be used to produce temporary immunity. If externally produced antibodies are introduced into a person's blood, the result is passive immunity. Passive immunity lasts only for a short time because the immune system eventually destroys the foreign antibodies. Passive immunity can occur naturally or by deliberate exposure. Natural passive immunity occurs when antibodies are passed from a pregnant woman to her fetus across the placenta or to an infant through breast milk. For some diseases, antibodies from humans or animals can be injected into an individual. For example, people who have been bitten by rabid animals are injected with antibodies for the rabies virus. So how do public health measures and medications fight diseases? Well, public health measures help prevent diseases by monitoring and regulating food and water supplies, promoting vaccination, and promoting ways that avoid infection. Antibodies can kill bacteria, and some antiviral medications can slow down viral activity. In 1900, more than 30% of the deaths in the United States were caused by infectious disease. In 2005, less than 5% of the deaths were caused by infectious disease. Two factors that contributed to this change are public health measures and the development of medications. In 1854, Dr. John Snow learned through interviewing residents and mapping that the source of the London cholera outbreak was a water pump. This is a major event in the history of public health. The field of public health offers services and advice that help provide healthy conditions. Promoting childhood vaccinations and providing clean drinking water are two important public health measures that have greatly reduced the spread of infectious disease. Medications such as antibiotics and antiviral drugs are other weapons that can fight pathogens. An antibiotic is a compound that kills bacteria without harming its host. In 1928, Alexander Fleming noticed that a mold, Penicillium notatum, seemed to produce something that inhibited bacterial growth. Research determined that this something was a compound Fleming named penicillin. Researchers learned to mass produce penicillin just in time for it to save thousands of World War II soldiers. Antibiotics have no effect on viruses. However, antiviral drugs have been developed to fight certain viral infections. These drugs generally inhibit the ability of diseases to invade cells or to multiply once inside the cells. So why have patterns of infectious diseases changed? Well, two major reasons for the emergence of new diseases are the ongoing merging of human and animal habitats and the increase in the exotic animal trade. Misuse of medications have led to the reemergence of diseases that many people thought were under control. By 1980, many people thought that a medicine had conquered infectious disease. Vaccination and other public health measures had wiped out polio in the United States and had eliminated smallpox globally. Antibiotics seemed to have bacterial diseases under control. Some exotic diseases remain in the tropics, but researchers were confident that these epidemics soon would be history. In recent decades, a host of new diseases have appeared, including AIDS, SARS, hantavirus, monkeypox, West Nile virus, Ebola, and the avian flu or bird flu. Other diseases that people thought were under control are emerging as a threat and spreading to new areas. Pathogens are also evolving in ways that enable them to infect different hosts. As people clear new areas of land and as environments change, people come in contact with different pathogens. The exotic animal trade for pets and food has also given pathogens new opportunities to jump from animals to humans. In 2003, Dormouse from Ghana spread monkeypox to prairie dogs in the United States, which then infected humans. And the spread of SARS also has been associated with the wild animal trade. So the misuse of medications has led to the reemergence of disease that many people thought were under control. For example, many strains of the pathogens that cause tuberculosis and malaria are evolving resistance to a wide variety of antibiotics and other medications. In addition, diseases such as measles are making a comeback because some people fail to follow vaccination recommendations.